Alright, let's look at a couple more examples here with solving the radical equations, okay? These are going to be a little bit more difficult. We're going to have some equations that have two radicals in them, as you can see here. Alright, now it's actually not going to be that much harder, okay? Because step one is still to isolate the radicals, okay? You'll see that on this side of the equation I have a radical all by itself. On this side I also have a radical all by itself. So they are isolated. And so I'll go ahead and square both sides, because that's step number two, to square the function. Now again, when I square each side, that means that the square root and the squared term are going to cancel out because they're inverses of each other. And so I'll be left with 3x minus 17 is equal to x plus 21. Of course, from there, I just, step number 3, solve for x. So subtract the x. So I'll have 2x minus 17 is equal to 21. I'll add the 17 to both sides. And then I've got 2x equals 38, divide by 2, and x equals 19. Now you guys know how to check this? Hopefully you said plug it in for x, and that's exactly right. If you take this 19 and plug it in for x, then it'll hopefully end up giving you two things that are equal to each other. And if it does, that means that this really is a solution. If it doesn't, that means that you got to cross it out and there's no solution, or you made a mistake up here above somewhere. And so it's always a good idea to check that, especially when you're doing a test, or as we call them, celebrations. Alright, for now, in the interest of time, I won't check this one. I'll go ahead and go on to the second example here. Alright, now in this example, again, my first step is to isolate the radical. I've got two radicals on the same side, which means they're not isolated right now. And so I'm going to go ahead and add the square root of x to both sides. Now what that's going to do is it's going to get the square root of 4x minus 3 all by itself on this side, and it will get the square root of x all by itself on that side. So now what I can do is I can go ahead and I can go up and I can square both sides. Step number 2, square the function, because that will cancel out with the square roots, right? And I'll be left with 4x minus 3 equals x. I can solve that, subtract the 4x, get all the x's to the same side. That's always first priority, is get all the x's together. Okay, x minus 4x will be negative 3x. And then from there, I need to solve for the x by doing the inverse, dividing by 3. Negative 3 divided by negative 3, of course, is 1. So x is equal to 1. Again, I can check this out by plugging it into the equation above and making sure that it works out. Now, let's look at a couple more examples. Okay, these will be slightly different because we're actually going to end up with a quadratic equation here. Now, when you end up with a quadratic, you can solve it by either doing the quadratic formula or by factoring it. You actually have a choice of how you want to solve for it. My personal opinion is if I can factor it, I'm going to factor it, because the quadratic formula is often very long. Yeah, it's awesome too, but it's always very long, and there's lots of chances to make mistakes there, whereas factoring is pretty quick and easy if I can figure out how to factor it right away. Okay, so let's go ahead and work this third example here. The first step, of course, is to isolate the radical. It's isolated, it's all by itself here. And so now I'm going to square the function, square both sides. Of course, on the left side, the root and the square cancel because they're inverses. And so I'm left with 6 minus x equals, and then you'll notice on this side, I've got an x squared. It doesn't cancel out with the root because there's no root over there. So what I need to do, since I have an x squared and an x term, is I need to get everything over to the same side. Okay? I need the equation to be equal to 0. So what I'm going to do is I'm going to go ahead and add the x, subtract the 6. Okay? So add the x, subtract the 6, and I'm going to put all of those together. Now you'll notice that on this left side, 6 minus 6 is 0. Negative x plus x is 0, and so I'm left with 0 is equal to x squared plus x minus 6. Now I'm pretty familiar with factoring, and hopefully you are too after last chapter, that I can see right away that I can factor this to x plus 3, x minus 2. these two numbers multiply together to give me the negative 6, right? And then they add together to give me the positive 1 in front of the x here. So now that I have two things multiplied together to give me 0, either x plus 3 equals 0 or x minus 2 equals 0. And so I'm going to get two different answers here. Now, anytime I get two answers, that kind of makes me a bit nervous. So I'm actually going to go ahead and check this one. Okay, we're going to check it in our equation and make sure that it works. Okay, so first I'm going to take the x equals negative 3, and we're going to check that one. So we're going to go the square root of 6 minus negative 3 is equal to negative 3, right? That was the original equation. Root of 6 minus x is equal to x. Okay, now you'll notice when I do this, I get the square root of 9, because 6 minus negative 3 is the same thing as plus a positive. Okay, a lot of you do this thing where you make it a 6 plus 3 is equal to negative 3. Now we know the square root of 9 is 3, which is not equal to negative 3, which means I've got to take that solution out. It's not really a solution. Okay, so now since that one didn't work, I really better check the other one. So let's go ahead and check the other one where x equals 2. And so we've got the square root of 6 minus 2, hopefully, is equal to 2. Okay, so 6 minus 2 is 4. It is still the square root, and the square root of 4 is 2. So that one checks out. This one is my solution. Alright, so let's look at one more final example before we let you loose to start your assignment for this. Okay, again, we're going to start by squaring both sides because it's already isolated the radicals, right? So we'll square both sides. Of course, on the left side, the root and the squared cancel out because they're inverses. So I've got 6x minus 5 is equal to x squared. Okay, now I've got to solve for x. Again, since I have an x squared and a 6x, I need to move everything to the same side. So minus 6x plus 5 minus 6x plus 5, and when I do that, these cancel out, so I'm left with 0 is equal to x squared minus 6x plus 5. Okay, so from this point, I can go ahead and factor to use the quadratic formula. Again, I notice that this is pretty easy to factor. I can do minus 5 and minus 1. Those two multiply to give me the positive 5. Those two add together to give me the negative 6. So I've got x minus 5 equals 0 and x minus 1 equals 0. When I solve those, I get x equals 5. And when I add the 1, I get x equals 1. Again, having two answers always kind of makes me nervous. I want to double check. So let me plug in the 5. 6 times 5 is 30. Minus 5 is 25. So the square root of 25 is 5. Ah, that one checks out. Let's check the 1. 6 times 1 is 6. Minus 5 is 1. The square root of 1 is 1. So that one, actually, both of them work out. And since I checked both of them, I plug in the numbers. If you're not sure about what I just did, go ahead and write it out. Okay, you can write out the square root of 6 times 5 minus 5 is equal to x, and you can work it out from there. Okay, and hopefully you'll be able to do the work now. So good luck, and I'll talk to you next time.